Okay, so if you're watching this, this is for practice problem 2 in the notes from Friday. So you're going to want to turn to those. I'm going to go ahead and do that problem with you. So first of all, this question is asking how much heat did the water gain, okay? We've got two things, water and HCl. So I'm going to go ahead and label both of those. We have HCl and water. And we know there's going to be a QMC delta T. QMC delta T, okay? First of all, we have 100 grams of water and 100 grams of HCl. I always think grams is the easiest to do, so we've got 100 of each. The HCl had a temperature, I like to do this just because I don't want to mess this up. So I like to do a T1 and a T2. The HCl had a temperature of 44.6, so 44.6. And the water was initially at 24.6. After the reaction, the temperature of both substances combined was 31.3 degrees Celsius. 31.3 degrees Celsius. Okay, we know the specific heat of water. It's always 4.18 joules per gram degree Celsius. And if you look at practice problem 2, it's actually asking me for this value here, the Q of the water. Okay, so actually for this I can totally ignore the HCl and just do Q equals MC delta T for this. So that's exactly what I'm going to do. Let me go ahead and do my delta T's. I have 31.3 minus 24.6. That gives me 6.7 degrees Celsius. And then for delta T for the HCl, I'm going to get to that later, so I might as well do it now. 31.3 minus 44.6. That gives me negative 13.3 degrees Celsius. Okay, that's all the information from the problem. Let's figure out practice problem number 2. Again, we are just solving for this. So I can do Q equals MC delta T. I don't need my information for the HCl just yet. So I'm going to go ahead and plug that in. The mass is 100 grams. The C is 4.18 joules per gram degree Celsius. And my delta T is 6.7 degrees Celsius. Make sure my units cancel out. And I'm going to go ahead and plug that bad boy in. 100 times 4.18 times 6.7. This is going to give me 2800.6 joules. Okay? I'm going to go ahead and fill that into my chart. That is the answer for practice problem number 2. 2800.6 joules. Okay? Now if we go ahead and move on to practice problem 3, it says using the last problem's numbers, figure out the specific heat capacity of HCl. Okay, so now this is our question mark. We want to know this guy. Okay, but you're like, wait, hold on a second. I can't have two variables. I can't just do Q equals MC delta T because I don't have Q. You actually do. Because if the water absorbed this much energy, well, where did it absorb it from? It absorbed it from the HCl, right? So if this is a positive 2800.6, this is now going to be a negative 2800.6. We can do this because of the law of conservation of energy, right? We know that whatever was absorbed had to come from somewhere, and in this case, it's coming from the hotter HCl. So now I can do a second Q equals MC delta T for question number 3. Q equals MC delta T. This time I want to find C. So in order to isolate C, I do M delta T on both sides. M and M cancel out, delta T and delta T cancel out. That gives me C equals Q over M delta T. Okay. We go ahead and plug that in, all of our numbers. This is negative, don't forget, it is releasing energy, so we need to make it negative. It's also decreasing in temperature, so you'll see those negatives cancel out eventually. C's always got to be positive, right? Mass is 100 grams, and my delta T already calculated was 13.3 degrees Celsius. Okay, none of my units cancel out. That's fine. We're going to keep them. Negative 2800.6 divided by 100 divided by negative 13.3. This gives me an answer. C is equal to 2.1. I'm going to round up to 211, and we're going to take our units with us. Joules per gram degree Celsius. We know that's our unit for C, so that is exactly how we're going to solve both of those problems.